Okay, so insertion, sort. There's my numbers. All right, the way insertion sort is going to work is that we are going to we're going to start with a list of size 1 that is sorted. Then it's size 1, so it's sorted, obviously, right? Then we're going to say, okay, now we're going to move on to so that we have a list of size 2. And we're going to insert the 55 into the correct position in that list of size 2. And the way we're going to do that is we're going to compare the 55 with its adjacent to the left neighbor. If they're in the wrong position, we're going to swap them. Then once we get to bigger arrays, we're going to keep swapping it until it gets into the correct position. So we're going to take each of these numbers one at a time and insert it into the correct position in the array, in the portion of the array that is sorted. Okay, so the 55 is not, so if I'm looking at this as the 2-element array, the 55 is not in the correct position. I need to swap it, right? Okay. So now I have a list of size 2 that is sorted. Now I want a list of size 3 that is sorted. The way I do that, I compare the 92 and the 82. Are they in the correct order? Yes, they are. So I'm done. 92 has been inserted into the list into the correct position, so that I have a sorted list with 3 items now. All right, let's take a look at the 67. I compare it with the 92, wrong order, so I swap them. 7, was that 92?
Yeah.
Okay. All right, 67 and 82, are those in the correct order? No, so I swap them. See what I'm doing is I'm going down, comparing until it gets, comparing and swapping until I get it into the correct position. 67 and 55, they're in the correct order, so I'm done. Okay, so now I have inserted the 67 into the correct position in the list that I am forming. All right, let's insert the 90 into the list. 90 is in the is smaller than 92, so I'm going to swap those two. But it's bigger than 82, so I'm done. The 90 is in the correct position. So you get why it's called insertion sort, right? Make sense? Okay. All right, let's talk about the 38 now. 38 and 92 swap. 38 and 90 swap. 38 and 82 swap. 38 and 67 swap. 38 and 55 swap. And I'm done because I'm at the end of the array, right? This actually turns out to be a thing you have to be careful about when you're coding it, right? You can't just say, keep going as long as they're in the wrong order. You have to say, or you've reached the end of the array. Okay, I'll speed up a little bit. Doing the 15 now. 15 and 92 swap. 15 and 50 swap. 15 and 82 swap. 15 and 67 swap. 15 and 55 swap. 15 and 38 swap.
It's 99 50.
Thank you. Here too, huh? Yikes. How did I get 50? Let's see, I already made a copy, right? So now we're going to insert the 53. 53 and 92 swap. 53 and 90 swap. 53 and 82 swap. 53 and 67 swap. 53 and 55 swap. 53 and 38 don't swap, and I'm done. Now let's insert the 96. 96 and 92 already in the correct position, so I'm done. Almost done. So now we're inserting the 35. 35 and 96 swap. 35 and 92 swap. 35 and 90 swap. 35 and 82 swap. 35 and 67 swap. 35 and 55 swap. 35 and 53 swap. 35 and 38 swap. 35 and 15 don't swap. Now we insert the 43. 43 and 96 swap. 43 and 92 swap. 43 and 90 swap. 43 and 82 swap. 43 and 67 swap. 43 and 55 swap. 43 and 53 swap. 43 and 38 don't swap. One more time. Uh, 60 and 96 swap. Whoop. 60 and 96 swap. 60 and 92 swap. 60 and 90 swap. 60 and 82 swap. 60 and 67 swap. 60 and 55 don't swap. Okay, that's insertion sort. Turns out, I'm not even sure if I can explain why this is, but in practice, for whatever reason, insertion sort, I guess we should have talked about big O first. Let's talk about big O. Just take a guess. N squared, yeah. It's going to be N squared again. You can tell just by how many numbers I had to write on the screen, right? Just to analyze it in a little more detail, I'm having to go through the array n times, right? Even though, you know, the first time I actually only had to go through one element. The second time I had to go through two elements, but eventually it's gonna depend on n, right? So I'm having to go through the array n times. Each time going through the array, I have to do n comparisons, roughly, right? So it's going to be n squared. Questions about that? Okay. No.
Was that just the opposite of the bubble sort?
Not really. I can see where you're coming from on that, but it seems like it's opposite in some ways, but you're actually doing something different. And it actually, what I started to say and then stopped was, it actually turns out to be faster than the bubble sort or the selection sort in general. Are you playing with it?
Yeah, it's about half the speed. It's 12,000 milliseconds to 6,000 milliseconds, right around there.
So you mean twice as fast?
Twice as fast.
Yeah, yeah.
Takes half as.
Yeah, okay. I seem to recall doing this on Windows that, I don't know, maybe it sounds like you're not experiencing this, but
I'm on Mac, so.
oh, that would explain why. Okay,
Yeah.
but on Windows, if you do this, and I have asked a million people and no one can tell me why this is, but the selection sort is like blazing fast. And it must be some sort of a what do you call it when you make it faster? Optimization maybe on Windows or something that makes it faster. I don't know why, but if you run my little testing code on a Windows machine, in my experience in the past, anyway, selection sort is like way faster than insertion or bubble. But that's weird. Shouldn't be that way. Normally insertion's a lot faster. But again, so let me just say that, you know, if it's twice as fast, that's fine. But, and we'll talk about this more on Wednesday, when we're talking about, yeah, I changed my mind, but it's gonna be a little later. Because I have a meeting that goes till 3. The big O, the difference in big O makes way more difference than just twice as fast. Like if we come up with an algorithm that's twice as fast, we don't really even care. We want it to be like, you know, exponentially faster. So we'll talk a little bit more about that and make it sort of come to life a little bit on Wednesday. Let's just take a quick look at the code. So insertion sort looks even simpler than the other ones, right? Here's my for loop, just going, whatever it is I'm doing it num items times. Actually, num items -1, but I'm starting I at 1 because I don't have to look at the 0th item because it's automatically already in the, I don't have to have an iteration of my for loop to put the first item in the correct position. It just is. So I'm going to start with a list of size 2. And then so J gets I means, you know, if I'm inserting the 7th item in the array, I'm going to say J gets 7. And then I'm going to compare that item with the item to its left. And as long as they're in the wrong order, I'm going to swap them and subtract 1 from J. So if that isn't totally 100% clear, I would suggest just taking 5 minutes sometime later and look it over. I think 5 or 10 minutes and you should be able to get this figured out. Am I done? I didn't type big O of n squared. So it might be getting a little bit monotonous at this point, right? We've done 3 sorts so far, and all 3 of them have been big O n squared. I promise you things will get a little more interesting next time. And that's all I have until next time. So I will